Good morning, children. This video we are going to see some compounds, that is we have to find out the IUPAC name for some compounds. Okay. Already in the previous video we discussed about one example, right? So next one we are going to discuss today. The second one, see the compound CH3 bond CH bond CH2 bond CH2 bond CH3. Here one methyl group is there. This bond CH3 is there. Okay. What we have to do? Here we have to remember the rules. Already we learned about the rules, isn't it? So first rule, what is the first rule? We have to identify the longest chain. Okay, we have to identify the longest chain. Okay, so just count longest chain is carbon atoms we have to count, isn't it? That's the longest chain, right? How many? So this is the longest chain. Next we have to count the number of carbon atoms. Got it? Right. So this is one. First carbon atom, second, third, fourth, 5. So this is the longest chain. It contains 5 carbon atoms. Okay. What is the root word of the 5? Root word is pent. Okay. Root word is pent. That is 5 means pent. So first we have to identify the longest chain, and we have to know about the root word. Okay. 5 means 5 carbon atoms means what is the root word? The root word is pent. This is as per rule 1. This is the first step. Second step, we have to check whether substituent is present in that compound. Okay. Here one substituent is present. This is the substituent. Already we discussed about substituent, isn't it? So this is the substituent. So carbon chain is numbered from left closest to the substituent. This is also as per the rule only. Next we have to identify whether substituent is there. Next we have to give the number which is closest to the substituent. Okay. What is the number called? The number is called the locant number. So here substituent is present. So we have to give the number from the left side. Why? Because this is the closest to this carbon atom is closest to the substituent. Okay. So we have to put the number from left to right. So we have to put number 1, 2, 3, 4, 5. We gave the number. Okay. So second step is over. Next third step, all are single bonds. Hence suffix is ane. Okay. Next what we have to do? We have to identify whether the carbon atoms are connected by single bond or double bond or triple bond. Here all the carbon atoms are connected by single bond only. So what suffix we have to use? We have to use the suffix ane, that is A-N-E. Okay. So third step is over now. Next step is we have to check the substituent. This substituent is a methyl group. CH3 means it is nothing but methyl. So the substituent is methyl group. It is located in which carbon atom? Second carbon atom. This is first carbon atom and this is the second carbon atom. So next we have to identify the number. Okay. This methyl group is located in the second carbon atom. So locant number is 2 for this substituent. Okay. Hence, what prefix we have to write here? We have to write the prefix to hyphen. That is hyphen means dash. We have to put one dash. Already we learned the rules, isn't it? So we have to put this locant number to dash. And what is this group called? Methyl. Okay. 2 dash methyl. That is the fourth step, right? So next what we have to write? We have to add all the things. What is the first one? 2 methyl. Okay, so this is the prefix. Next one, root word we have to write. Root word is pen. Okay, so plus A. 2-methyl plus pen plus A. Now we have to add all these things. So what you will be getting? You will be getting 2-methyl pentane. So what is the name of this compound? 2-methyl pentane. Okay, like this we have to find out the IUPAC name of the compound. Okay, clear children? Shall we move to the next one? Good. Next one is, look at this compound CH3 bond CH bond CH2 bond CH2 bond CH2 again bond CH3. Here in the second carbon atom, here C is connected with one CH2 group, also one substituent, that is methyl group is there. Okay. Now what we have to do as per rule 1, we have to find out the longest chain. Okay. So this longest chain contains 7 carbon atoms. How you get 7? If you count like this, 1, 2, 3, 4, 5, 6 carbon atom only. And why you are saying 7? You have a doubt, isn't it? So what I told you, we have to identify the longest chain. So we have to put the number from this to this. Like this we have to give the number. If you give the number starting from here, okay, then put 1, 2, 3, 4, 5, 6, 7. If you put the number like this, then you will get the longest chain. Suppose if you put the number from left to right, it will be getting 6 only. That will not come under the longest chain. Okay, so we have to put the number like this. Identify the longest chain. Okay, so see the number here, 1, 2, 3, 4, 5, 6, 7. From this to this. Okay, so the longest chain contains how many carbon atoms? The longest chain contains 7 carbon atoms. So what is the root word? The root word is hept. H-E-P-T. Okay, what is the root word? The root word is hept. Got it? Right. Second point, substituent is present here. This is the substituent. So carbon chain is numbered from the end. Like this we have to put the number, that is locant number. Okay, already I told you we have to give the number which is closest to the substituent. Next one, so we are giving the number like this, 1, 2, 3, 4, 5, 6, 7. Next one, see, all the bonds are connected by single bond only. All the carbon atoms are connected by single bond only. So what suffix you have to use? You have to use the suffix A-N-E. Got it, children? Right. Next one, here you have to see a substituent is present. The substituent is methyl group. Okay, the substituent is methyl group, and you have to find out the carbon atom. In which carbon atom the substituent is present? This one is 1, 2, 3. That is 1, 2, 3. In the third carbon atom, the substituent is present. Got it, children? Third carbon atom. This is the third carbon atom. So in the third carbon atom, the substituent is present. Okay. So we have to use the prefix 3-methyl. Okay. This one you know very well. The substituent is methyl group. This substituent is present in the third carbon atom. So we have to put 3-methyl. Okay. So next one, we have to connect all the things. What's the first one? 3-methyl. It is 3-methyl plus hept. Hept means what? How many carbon atoms? What's the root word? The root word is hept. Okay. Hept. Next one is A. Here all the carbon atoms are connected by single bond. So we have to use the suffix A. Now add all these things. 3-methyl pentane. Okay. The name of this compound is 3-methyl heptane. Got it, children? Clear? Good. Next one, see, CH3 bond CH2 bond CH2 bond CH, double bond CH2. Okay, here look at this compound. You can see the double bond here, isn't it? Okay, so first what we have to do, we have to find out the longest chain. So 5 carbon atoms are present in the chain. Okay, so this is the longest chain. How many carbon atoms are present? 1, 2, 3, 4, 5. So 5 carbon atoms are present in the chain. So what is the root? What's the name of the root word? The root word is pent. Okay, 5 carbon atoms are present in pent. What we have to use the root word? The root word is pent. Okay. Next one, carbon to carbon. Okay, carbon here, all the carbon atoms are connected by single bond only. But if you look at here, carbon to carbon is double bond. Okay, double bond means what suffix you have to use? You have to use the suffix E. Whether if it is a triple bond means you have to use the suffix I. Okay, so carbon to carbon double bond is present. So we have to use the suffix E. That is the next step. Got it, children? First step and second step, no doubt, isn't it? Let me move to the next step. Carbon chain is numbered from N. Okay, double bond has lowest locant number. Already we saw here. If substituent is present, means that substituent is closest to that carbon atom. If it is closest to that substituent, means we have to give the number. Here, but here carbon to carbon double bond is present. So we have to give importance here only. We have to give the number from right to left. Okay, right to left. So we have to give the importance for the double bond here. Here no substituent is present. Double bond only we have. Okay, so we have to give the number like this. So see here, this is the number 1. This is number 2. We should not put the number from left to right, because here you are seeing carbon to carbon double bond, isn't it? So if it is double bond or triple bond is there, next we have to give importance for the double bond and triple bond. If there is no substituent, in that case, we have to start the number from the double bond. So start the number here, 1, 2, 3, 4, 5. Got it? So like this we have to give the locant number. Next one, locant number of double bond is 1. Okay, so see the locant bond here, double bond is present now. So we have to give the number, start the number from 1. So the answer is 1. Okay, right. Next one, what is the suffix? Suffix already I told you, E. Why? Because double bond is present. Okay, so what you have to do? You have to write 1 dash E. Okay, 1 means locant number starts from 1. First carbon atom, and second one we have to see the suffix. Okay, double bond, carbon to carbon double bond is there. Double bond means we have to use the suffix E. Okay, so E-N-E, 1 dash E. Next what we have to do? How many carbon atoms are present? 5 carbon atoms. So pent. Okay, the root word is pent plus, already we saw 1 dash E. Just to join this, we will get pent dash 1 dash E. Okay, the name of this organic compound is pent dash 1 dash E. Got it, children? Understood? Right. So few more examples we can see in the next video. Next we can move to the manufacture of ethanol. Okay, it's a very important 5 mark question. First one, we have to start from the molecular formula as well as structural formula. Ethanol is otherwise known as alcohol. Okay, the molecular formula of ethanol is C2H5OH. Okay, 2 carbon atoms, 5 hydrogen atom, and 1 functional group is there. Okay, so what is the molecular formula of ethanol? It's a 1 mark question. The molecular formula of ethanol is C2H5OH, and this is the structural formula of ethanol. Okay, this is the structural formula. See, carbon connects with the carbon. Again, here hydrogen bonds are rules. Okay. What is the first one? First one is dilution of molasses. Dilution of molasses. Okay. Before that, I'll tell you. In the laboratory, not only in the laboratory, as we can get the ethanol in industries by ethanol is actually manufactured in industries. Okay, ethanol is manufactured in industries by using the molasses. Molasses, it is nothing but a sweetener. Okay, this molasses is mainly obtained from sugar from the sugarcane. Okay, sugar from sugarcane. This molasses is a dark colored syrupy liquid and it contains 30% of sucrose. Sucrose is nothing but the chemical name of sugar is sucrose. Got it, children? So actually we are getting from molasses only. This molasses is a dark colored syrupy liquid. Okay, it's a liquid. It contains 30% of sucrose. Okay, sucrose is nothing but sugar only. Right. The first step is dilution of molasses. Okay. First of all, molasses is diluted with water. Already I told you, molasses is nothing but a dark brown liquid, syrupy liquid. This molasses is diluted with water. This is the first step. Okay. Second one, addition of nitrogen source. Molasses, it acts as food for yeast, okay, during fermentation process because it contains, that is molasses contains enough amount of nitrogen substances. Suppose if the nitrogen content is very poor, okay, then in that case it can be protected. Okay, it can be protected by adding ammonium sulfate or ammonium phosphate. Got it? Right. Next one is addition of yeast. Now we got one solution after adding ammonium phosphate and ammonium sulfate, isn't it? So that solution is collected in a large flask. Okay, it is collected in a large fermented flask. And yeast added into that large tanks. Okay, that fermented mix already got one solution by adding ammonium phosphate and ammonium sulfate. In that solution, that solution is collected in a large tank. Okay, and yeast is added into it. This mixture is heated at about 303 Kelvin and just kept it for 2 days, few days. Okay. After that, in that yeast, some enzymes are present. That is, invertase and zymase enzymes are present. These enzymes convert the sucrose into alcohol, ethanol. Okay. So what is the process? First one, sugar I already told you. C12H22O11 plus water gives, in the presence of enzyme invertase, it turns into glucose and fructose. The formula of glucose is C6H12O6 and fructose also the same formula only. Okay. So next one, we got glucose and fructose, isn't it? That glucose and fructose, the enzyme, in the presence of enzyme zymase, it turns into ethanol as plus carbon dioxide is released. Got it, children? So this fermented liquid, after getting this ethanol, this is a fermented liquid. This is called wash. Okay, wash. WASH. Next process is distillation of wash. I told you that fermented liquid is called wash, right? Wash contains 15 to 18% of sucrose. Okay, wash contains 15 to 18% of that molasses, that sweetener, right? 15 to 18% it contains. Got it? So after this one, this wash on distillation, fractional distillation process. Fractional distillation is mainly used to purify chemicals and also used to separate the mixtures. Okay, this on fractional distillation, due to this aqueous solution of ethanol, okay, converts into This is called a rectified spirit. This rectified spirit can be reflexed over calcium oxide, that is quicklime. Reflex means flow backwards. Okay, it should be reflexed for 5 to 6 hours, and again it should be make them to allow or settle for a few days. Okay, few days. After that, further on distillation, it changes into absolute alcohol, that is 100% alcohol. It changes. Okay, in this manner, it changes into 100% alcohol. Okay, so this is the process, children. This is the manufacturing process of ethyl alcohol. Okay, what are the steps we have to follow? First one is dilution of molasses. Okay, second one is addition of nitrogen source. Third one is addition of yeast, and the last one is the distillation of wash. Got it? So these process we have to follow. Finally, we get the absolute, that is 100% ethyl alcohol we get during this fermentation process. Okay, this fermentation process is very important. Okay, got it, children? Good. Next, we can move to the physical properties of ethanol. Ethanol is a colorless liquid. It has a pleasant smell and also it's a burning taste in nature. Okay, ethanol is volatile in nature. The meaning for volatile is easily it gets evaporated. Got it? Next one, ethyl alcohol is miscible with water in all ratio, all proportions. Okay, ethanol is soluble in water. These are the three general main properties of ethyl alcohol. First one, ethyl alcohol is a colorless liquid. It has pleasant smell and also it has burning taste. Okay, ethyl alcohol is volatile in nature. It evaporates easily. Next one, ethyl alcohol miscible with water in all proportions. Got it, children? Next, we can move to the chemical properties of ethyl alcohol. Right? First one, dehydration process. Got it? What's the first one? The first one is dehydration process. Dehydration means you know very well. Loss of water. Loss of water is nothing but dehydration. Okay. Here, so this is ethyl alcohol. CH3, CH2OH is ethyl alcohol. So ethyl alcohol, or otherwise we can say C2H5OH. If you count the carbon atoms, so how many carbon atoms? 2 carbon atoms. How many hydrogen atoms? 5 hydrogen atoms. OH, functional group. Okay, so C2H5OH also you can write for ethyl alcohol, as well as you can write CH3, CH2OH also. Both are same only. So ethyl alcohol, on treating with concentrated sulfuric acid, this H2SO4 is nothing but sulfuric acid. Ethyl alcohol on treating with concentrated sulfuric acid at 443 Kelvin, it changes into ethene. Okay, C2H4 ethene, as well as water molecule is formed. Got it, children? Dehydration process. Dehydration means loss of water. Ethyl alcohol on treating with concentrated sulfuric acid at 443 Kelvin, it changes into it reacts with concentrated, that is ethyl alcohol reacts with concentrated sulfuric acid to form ethene as well as water molecule. Got it? Right. Second one, reaction with sodium. Reaction means what? Ethyl alcohol reacts with sodium. So this is ethyl alcohol reacts with the sodium, forms sodium ethoxide. Okay, the compound is sodium ethoxide and its formula is C2H5ONA as well as hydrogen gases liberated. Okay, so ethyl alcohol on reacting with the sodium, it forms sodium ethoxide plus hydrogen gases liberated. Third one is oxidation process. Okay, this is the oxidation process. So ethyl alcohol on oxidation in the presence of KMnO4, that is potassium permanganate, or K2Cr2O7, that is potassium chromate, it changes into ethanoic acid. Okay, ethanoic acid. water. Got it, children? So ethyl alcohol on oxidation in the presence of KMNO4. KMNO4 is potassium permanganate or potassium chromate. It changes into ethanoic acid as well as water. This is also one of the property. Next one is esterification process. Okay, esterification process. Here, ethyl alcohol, when it reacts with ethanoic acid, okay, the CH3COOH, we are treating with ethyl alcohol and the presence of concentrated sulfuric acid, it changes into ethyl ethanoate plus water molecule. Got it? Ethyl alcohol plus ethanoic acid or acetic acid CH3COOH in the presence of concentrated sulfuric acid, the compound got as ethyl ethanoate, that is CH3COO, C2H5 is ethyl ethanoate plus water molecule. Got it? Right. Next one is dehydrogenation process. Dehydrogenation means what? Removal of hydrogen. Got it? What is the meaning for dehydrogenation? Removal of hydrogen. Here, ethyl alcohol on treating with heated copper, the vapors of this ethyl alcohol. Okay, the vapors of this ethyl alcohol on treating with the heated copper at 573 Kelvin, it changes into acetaldehyde. Okay, CH3CHO is acetaldehyde plus hydrogen gases liberated. Okay, hydrogen gases liberated. Here I told you, no, children, for esterification process we got one compound, carboxylic compound. No, that compound has some very sweet odor. Okay, sweet odor we can, fruity odor. Sweet fruity odor we can get. That is carboxylic acid compound, ethyl ethanoate. Next, dehydrogenation, I told you, it's the removal of hydrogen. So, the vapors of ethyl alcohol on treating with the heated copper at 573 Kelvin, it changes into acetaldehyde as well as hydrogen gases liberated. Next one is combustion. You know very well combustion means burning, right? So, ethyl alcohol on treating with oxygen, it changes into carbon dioxide gas as well as water molecule as okay. Combustion, ethyl alcohol plus oxygen gives carbon dioxide as well as water molecule. Got it? These are some of the chemical properties of ethyl alcohol. Definitely you will get the 3 mark questions you will get from this. Okay. So you have to learn the formulas also. Also you should balance the equation. Okay. Without balancing the equation you should not write. You won't get full marks for that. Next one is uses of ethanol. Ethyl alcohol is generally used to kill germs, bacteria, okay, and it is used as an anti-freeze in automobile radiator. That is, it lowers the freezing point, okay, and ethyl alcohol is used as an antiseptic for sterilizing wounds in hospitals. And nowadays we are using hand sanitizers, isn't it? It contains, hand sanitizers contain ethyl alcohol only. Okay, and ethyl alcohol is also used for flavors, and ethyl alcohol is mainly main uses of ethyl alcohol. It is used as an antiseptic. Okay, and it is used in making methylated spirit. Methylated spirit in the sense. It contains 95% of ethyl alcohol. The balance 5% it contains methyl alcohol. It's a poisonous substance. Okay. And already I told you rectified spirit. Rectified spirit in the sense it contains 95.5% of ethyl alcohol and balance 4.5% is water. Okay. And also it is used in making power alcohol. Power alcohol means it's a combination of petrol as well as alcohol. This is also one of the uses of ethyl alcohol. Okay. So next we can move to the ethanoic acid. Got it? Ethanoic acid. Acetic acid is otherwise known as ethanoic acid. So it's the molecular formula of ethanoic acid is C2H4O2. Okay, what is the molecular formula of ethanoic acid? The molecular formula of ethanoic acid is C2H4O2 and its structural formula. This is the structural formula of ethanoic acid. Here you can see the double bond, isn't it? So this is the structural formula. Next, manufacturing process of ethanoic acid. Manufacturing process is nothing but, here we saw, isn't it? It is this process. Actually, ethanoic acid, this is the ethanoic acid. Ethanoic acid on oxidation process on treating with potassium chromate as well as potassium permanganate. Okay, on oxidation process, this ethanoic acid on treating with KMNO4 is potassium permanganate and K2Cl2O7 is potassium chromate. It changes into, during this oxidation process, it changes into ethyl alcohol. Okay, so ethyl alcohol, already we saw this in the ethyl alcohol chemical properties we saw in oxidation process. The same thing only for ethanoic acid also. Ethanoic acid is ethanoic acid got in this process, in this reverse process. Ethanoic acid on treating with the potassium permanganate or potassium dichromate indicators on oxidation process. Okay, oxidation process. In this manner we get the ethanoic acid, or otherwise we can say acetic acid. That reverse process only here for manufacturing of ethanoic acid. Next we can move to the chemical properties of ethanoic acid. First one, reaction with metal. Okay, manufacturing process. First, second one is the chemical properties. Before that we can see the physical properties we have to see, isn't it? Physical properties of ethanoic acid. This ethanoic acid is also a colorless liquid only. Okay, it has some unpleasant odor. Its odor is not, it will not good. Okay, it has some bad odor. It has unpleasant odor and also it is a colorless liquid. Okay, and ethanoic acid is somewhat sour in taste. Sour in taste. Okay, and ethanoic acid is mixed with water in all the proportions like ethyl alcohol. Okay, these three are the general properties of general properties of ethanoic acid, or otherwise acetic acid. Got it? Second, we can move to the chemical properties of ethanoic acid. First one, reaction with metal. Okay, reaction with metal. Here, acetic acid or ethanoic acid, CH3COOH is ethanoic acid or acetic acid. This on reaction with zinc. Zinc is nothing but a metal, isn't it? So, acetic acid on treating with zinc, it forms zinc acetate. The formula is CH3COO twice Zn. This is zinc acetate as well as hydrogen gas is released. This on reaction with metal. Okay. So, next one, reaction with the carbonates. Reaction with carbonates. So, acetic acid or ethanoic acid on treating with the sodium carbonate. What's the formula for sodium carbonate? Na2CO3. So, ethanoic acid on treating with the sodium carbonate, it forms sodium acetate. The formula is CH3COONA plus carbon dioxide gas as well as water is released. Okay. During this process, brisk effervescence takes place. Why? Because carbon dioxide gas is released. Got it? Right. Next one, reaction with base. Reaction with base. Ethanoic acid on treating with the sodium hydroxide. NaOH is sodium hydroxide. It is a base only. Both reacts to give sodium ethanoate as well as water molecule. Okay. What is the formula for sodium ethanoate? CH3COONA. This is sodium ethanoate. Okay. So, ethanoic acid on treating with the base sodium hydroxide, it turns into sodium ethanoate as well as water. Next one is decarboxylation process. Okay, decarboxylation process. Decarboxylation means removal of carbon dioxide. Okay, what is the meaning for decarboxylation? Decarboxylation means removal of carbon dioxide. Look at this equation. CH3COONA. This is nothing but sodium ethanoate. On treating with NaOH as well as calcium oxide. CaO is calcium oxide. This NaOH as well as calcium oxide combination is called soda lime. Okay. In the ratio 3:1. They react to form methane gas as well as sodium carbonate is evolved. Okay, sodium carbonate is produced. Methane gas is produced. Along with that, sodium carbonate is produced. This is the decarboxylation process. A carbon dioxide is removed from here. Okay, removal of carbon dioxide. So, sodium ethanoate on treating with sodium hydroxide and calcium oxide. This is called the soda lime mixture. In the ratio 3:1, both react to form methane gas as well as sodium carbonate is produced. Okay. Finally, uses of ethanoic acid. What are the general uses of ethanoic acid? Ethanoic acid is mainly used as a food additive, preservative. In the pickles, we use some we use vinegar, isn't it? Vinegar contains acetic acid. It is nothing but ethanoic acid only, but it has some unpleasant odor. Okay, along with this additive as well as preservative, ethanoic acid is mainly used in pharmaceutical companies. Okay, it is used for manufacturing of plastics, and it is also used as a solvent for dyes, pigments. Okay, along with that, it is also used for food essence. Okay, so these are some of the uses. Mainly, it is used as a food additive, and then it is used as a preservative. It is used in pharmaceutical companies. It is used in industries, used in the manufacture of plastics, and also it is used as a solvent for dyes. These are the uses of ethanoic acid. Okay, so what are the things today in the video we discussed to children? One is about the manufacturing process of ethanol, isn't it? Manufacturing process of ethanol, and some IUPAC organic compound, how to give the IUPAC name of the organic compounds. That also some few examples we saw. Along with that, we discussed about the manufacturing process of ethanol, and then physical properties, general chemical properties of ethanol, followed by the uses. Next, we saw about the ethanoic acid, its physical properties, general chemical properties as well as uses. These things we discussed, isn't it? In the next video, we can discuss about a few examples of how to name the IUPAC name for the given compound. Also, we can discuss about the soap manufacturing like that. Okay, children. All the things, what are the things we discussed today? Everything you just go through. The remaining we will see in the next video. Thank you.